Hello, my name is Peter. Welcome to another video about sailing vessel Silverheels, my Rhodes 22. One of the projects I did last year on the boat was to install a refrigerator and a 100-watt solar panel to provide power for that refrigerator. I built a framework that kind of hung off the aft railing to support the panel. And that worked out all right, except that over the course of the sailing season, I discovered that one 100-watt panel didn't provide enough power for the refrigerator. That location wouldn't really support a larger panel or certainly a second panel without being seriously in the way of something. So after scratching my head over that problem for a while, I decided that what I need, or at least needed to investigate, was the possibility of having some kind of structure at the stern of the boat that would hold solar panels up above head level. A structure like that is most commonly referred to as an arch, so that's the term I'm going to use. Now, initially, I thought I would take the direction of buying a pre-made arch. Specifically, I was looking at models made by a company called Atlantic Tower, and they're very nice looking units. A little bit pricey, a couple $1,000s, a little more. But it wasn't the price that kept me from taking that route. I was really concerned that after spending the money, I wouldn't be able to make it work on the boat. I was concerned both about exactly how it would attach to the boat and how it would interact with the stern railing. So the direction I decided to take instead is to build an arch using stainless steel tubing and off-the-shelf fittings. So I spent a large part of the winter modeling this and refining the design. And so I think the best place to start is to take a look at that. So here we are with a crude mock-up of the cockpit of my Rhodes 22, and your Rhodes 22 if you have one. So the application we're using here is Sketchup, and this happens to be on a Macintosh computer. So unfortunately I don't have a model for the original factory aft railing, so we don't have that for comparison, but I'll click a couple of buttons here and I'll show you. There we go. What I have in mind for the solar arch. Now, I hesitate to use the word arch because to me the word arch implies curvature, and there is no curvature here. This is all straight pieces of tubing with off-the-shelf connectors. The tubing is 1 inch outside diameter that came from Defender. I got it from Defender because I only live an hour away from them, and so it's easy for me to drive down and pick the tubing up. Having long pieces of tubing shipped by UPS or FedEx would have been quite expensive. Defender sells 2 grades of tubing, a heavy duty and a lighter duty, just based on the thickness of the wall. And this is actually a mixture of the 2 weights for reasons I'll touch on a little later. The fittings came from McMaster Carr. We're reusing here, and I haven't drawn them in all that well, or at all, the attachment points that the original aft railing used. 1 on each side and 2 at the aft. In addition, I've created 2 new attachment points right at the corners, port and starboard. to really give me a corner railing so that these rail tubes can fit around the corner without, again, having to do any bending. So just to give you a sense of scale, I can put this guy into the picture. His name is Chris. Uh, he's about 5'9", I estimate, so that gives you an idea of the scale of things. As you can see, standing in the cockpit floor, the top of the arch is well over the head of most anybody. The height of this is to some extent chosen because it makes it possible to still use the swim ladder on the back without having to go through contortions. So I can almost stand on the seat. I'm about 5'7.5", just by ducking my head a little. And on the subject of the swim ladder, one of the added features I got here on the original railing, you had to climb over the aft rail, but I designed in a gate back here so that I can get up and down the swim ladder on and off the boat without having to duck. One of the things you may notice here is that the whole construct is not symmetrical. And again, since I'm reusing the aft mounting points, which are not symmetrical from the factory, that was a given. And the reason they're not symmetrical is that the outboard motor, which I didn't even try to draw, lives over here. So that a lot of the peculiarities of the design came out of that fact that were not symmetrical ports of starboard. One other thing I want to point out while we're on the subject of the aft mounts is for the side mounts, I didn't modify anything. I just reused them as they were. For the rear mounts, I built some shims. You'll see this a little more clearly later, to change the angle of the aft vertical pieces so that they'd be, again, more or less vertical as opposed to being tipped in somewhat towards the bow. Okay, so let's take a look at the solar panels. Those are 100-watt solar panels, which hopefully will be enough to keep the refrigerator powered. And they are mounted in a way, again, I'll show you in real life as opposed to on the video, but they're mounted in a way that they can both pivot port and starboard. So I wasn't sure I was going to be able to implement a tilting feature, but I was, and I think it's going to be useful. Putting those aside for the moment, you may notice that there's a kind of a cutout here in the front area of the top. And the reason for that is, oh wait, I'm getting ahead of myself. One of the aspects of this is that the factory mast crutch that catches the mast when it's lowered wouldn't work anymore. So I had to come up with a substitute, which is similar in design to the General Boat's crutch, except it just mounts directly to the arch. And one benefit of this is that the full mast crutch, which rides on the transom, is about 6 feet long and not easy to store on the boat if you wanted to. And there's reasons that could be useful. Whereas this is much smaller and it actually breaks down into these component pieces, so it can quite easily be stored on the boat. But getting back to the notch in the front, I discovered fairly late in the design process that although when lowering the mast, um, the mast would clear the arch, the boom would not. That would hit. So that's the reason for the cutout. It was a bit unfortunate. I think it makes the whole thing a little less strong and less rigid, but there was nothing to be done. That's the mast down. Just to put things back here, we'll put the solar panels back. I also modeled the mast when it's up, and because I was concerned about the aft stays, but we do clear those by several inches. And one last little thing you may notice that there's an additional piece of hardware in the center of the top. And the reason for that is, in the years I've had the boat, I often thought that having a radar might be nice. But although I could figure out various ways that a radar dome might be mounted, there's no way that I could figure out a good way to put a display for the radar anywhere in the boat. But then I discovered that Furuno makes a radar that can interact directly with an iPad for the display, so you don't need any kind of dedicated display equipment. So I have no plans to do anything about this season, but I just allowed for an attachment point so that I might do that at some point in the future. All right, I think that's enough of an overview, and it's time to go on to building and installing the actual arch. So here in the workshop, we're doing the assembly of the top portion of our solar arch. And I just wanted to go over a couple of points about how I'm going about this. So this is mostly about how I'm going about handling the connections. I've got a variety of these stainless steel fittings that will join sections of stainless steel tubing. And these are meant to be held in place with set screws that just press against the tubing. And I'm not really satisfied with that as a solution in this instance. So here is one of the set screws that came with the fittings I bought. This is actually called a cone point. I don't know if that's will really hold more firmly than a flatter tip, but that's what we're starting with. So, and this is what I thought I would use instead. This is a button head bolt that's a 1/4 inch, 28 threads per inch, same as the set screws. And using this would require drilling and tapping holes in the tubing. So here's a joint where I've done that. I've drilled and tapped into the tubing here, which is a bit of a process to go through. And here's a joint where we've got the bolts in place, and I can demonstrate the issue here. Well, it doesn't show up as well as I'd like, but the problem is that the bolts don't apply the same pressure against the tubing that the set screws do. So while it'll certainly hold, it's not as stiff as I would like. So this is what I'm going to use instead for the connections. This is a set screw with an extended tip. According to the McMaster car catalog, it's also sometimes called a dog point set screw. So this will give me the same positive connection between the connectors and the tubing that the bolt will, but also apply the pressure against the side of the tubing, which seems to give me a more rigid connection. And one final note on this process: this is something I've created that is allowing me to accurately place this holes in the tubing, and it's a set screw that I've drilled a 7/64 hole through. So when I want to create a hole in the tubing, I put this set screw into the threaded hole in the fitting, and then drill through to create the initial hole in the tubing, and then move the connector piece aside and make a larger hole. And a final note: when I get to the point of final assembly, and I'm not there yet, I'll be adding some Loctite to each set screw, again providing a greater comfort factor. So that's how I'm going about it, but I have to get on and drill a lot more holes. So the assembly of the top portion of our solar arch is finally complete. And over the course of assembling and disassembling and reassembling pieces of this, I've developed a slight variation on the joints and how I do them that helps with that process. So I wanted to tell you about that. So after drilling the initial 7/64 pilot hole, and then drilling a 5/32 hole that will accept the extended tip of the set screw, I've used a 1/4-inch drill bit to create a depression around the hole. And what that does is, with just the hole, and you have to hit this exactly. With adding the depression means you can kind of get part way in and then wiggle things around and get a final alignment that way, and that really does make it much easier. The only other tip that I have at this point is that drill bits are not lifetime purchases. They're consumables. So if you're going to do something like this, buy yourself a few brand new drill bits in the appropriate sizes, preferably something that's intended to drill into stainless steel, like a cobalt drill bits, which I know are at Home Depot, and I happen to get mine again through McMaster Car. But having good drill bits also makes this process much easier. Out here at the boat, we've done some preparations for the installation of the new solar arch. We've removed the aft railing, and we've added a framework built out of 2x4s that will support the top of the arch during the assembly process. So that's just resting on the cockpit floor, and the top is then parallel to the cockpit floor, which doesn't really make it quite parallel to the waterline, since the cockpit floor tips a little bit back towards the stern, but it's close enough, and it's a frame of reference. As I believe I mentioned, we're going to be reusing the mounting hardware for the stern rail that came on the Rhodes 22 from the factory. And so this is the side fitting, one on each side and two on the aft. As it happens, the factory railing was 7/8 inch outside diameter, but we're using 1 inch outside diameter tubing for maximum strength. So that left us with a bit of an issue here. The 1 inch tubing from Defender is available in two different weights or thicknesses. There's a regular and a heavy duty. The regular with the thinner wall happens to have an inside diameter that's just a little greater than 7/8 of an inch. So the approach we're going to take here is to insert a short piece of 7/8 inch tubing into the fitting, and then we'll just take our 1 inch tubing and slide it over that, and we'll of course have that'll be bolted into place. We'll be using a similar technique with the aft mounting points for the railing, but we had another couple of issues here as well. In the factory installation, these supports were mounted directly to the side of the boat here on the transom, and that tips inward towards the bow a little bit, and we didn't want that. We wanted these to be more or less perpendicular, these pieces. So we needed to create shims, and these are starboard, to change the orientation of the fitting, and therefore the pipe that's going to rest in here. So the angle on this, by the way, is 12 degrees. And there's a similar piece, happens to be made out of wood, not starboard, on the inside with an offsetting taper, so the two sides are parallel to each other. So that's here on the starboard side. There's an additional issue on the port side. As I mentioned, the aft supports are not symmetrical, and the one here to port is much further outboard than the starboard one. And because of the curvature of the transom, that meant we needed to space this out further away from the transom, so it would be on the same plane, kind of perpendicular to the center line of the boat with each other. And so after doing some careful measurement, that offset I determined was pretty close to 1 inch, so we've got an additional 1 inch of starboard spacing out the fitting here on the port side. And as a final bit of preparation here on the boat prior to assembly, we are going to have uprights here close to the aft corners of the cockpit. There's probably a nautical term for this part of the boat, but I don't know what it is. And so I found this bit of hardware at Defender, and that will swivel around and in and out. So there shouldn't be any problem getting the tubing that goes in here to meet the fitting that'll be on the top of the arch. So this is backed up on the inside by a 1/4 inch aluminum plate for added strength there. So I think it's time to assemble the arch.
Well, that's how the major components go together. Everything needs to be tightened up, of course, and I need to then spend a lot of time doing more hole drilling so that the extended point set screws can be used in place of the standard set screws, which should help make everything nice and rigid, I hope. And there's railings that need to be added as well. So, more work. So while the panel is still here in the workshop, I wanted to take a minute and show you what I've done to allow the panel to attach to the solar arch frame. So basically the panel is going to rest on the forwardmost and aftmost port to starboard frame tubes. So this would represent one of those. And what we've got is slide bolts, one near each of the four corners, and those will serve as the attachment points of the panel to the frame. So there'll be holes in the tubing out on the frame and to accommodate the bolts. So this piece doesn't actually have the hole. But these will not just be attachment points, they will also be pivot points. So by disengaging two of these, the other two will act as hinges and allow the panel to be tipped up either to port or to starboard to hopefully be able to catch some more sunlight early or late in the day. So in order for that to work correctly, the bolt actually needed to be outside of the solar panel frame. Otherwise, it would tend to bind up as it was pivoted. So to accomplish that, we've got this piece of angle aluminum. One side of that is attached to the frame of the solar panel, and we've attached the slide bolt to the other side. One other thing I've done here is attach some 1/4 inch starboard, both here to the solar panel and to the outside face of the angled aluminum. And that's so that I can minimize the amount of metal-to-metal contact between the panel and the hardware here and the tubing that's part of the solar arch. I don't really know that this is necessary, but it seemed like a good idea to me. One feature of these slide bolts is that they are sold as being padlockable. So there's a little hole here, about 1/4 inch, and another one over here. So you could slide a padlock through one of those, and that would prevent the slide bolt from sliding. Now, I'm not interested in locking these, but they will also accommodate a quick pin, so that I can use that as kind of a safety feature to make sure that the slide bolts stay in the position that I put them in. And finally, to facilitate the tilting of the panel that I mentioned earlier, I mounted this piece of U-channel to the solar frame, and there will be a piece of the solar arch. There will be a piece of tubing that will live right beneath that. Remember, here we're upside down. And mounted to this are two bars, a longer one and a shorter one, that can be used to prop the panel up. So there'll be some holes in the piece of tubing, and we can line up the hole at the end of the bar with a hole in the tubing and kind of lock that into place. And the short bar will accommodate low angles, and longer bar will accommodate higher angles. We can go up to about 50 degrees, which is should be plenty. So some time has gone by, and we have finally managed to complete the assembly of the solar arch. So we've got railings in place now, and a few things attached to railings. Our life sling is over there, and we never had a home for the boat hook before, and now it's attached to the aft railing, which also has the block for lifting the outboard. The yellow line there is my dinghy towing line, and the Fortress FX7 anchor that used to live up on the bow is now mounted back here where it is much more accessible. The solar panels are in place, as is the mast crutch for lowering the mast into. The uprights there were actually taken directly from the General Boats mast crutch. I just repurposed them. So we can take a closer look at one of those latches I tried to show you before. And so there's the safety pin we can pull, and then slide the latch back so it disengages the panel from the frame, and then the panel can lift, pivoting on the two outboard latches. And we've got the two bars, one on this side, one on the other, long one on the other side, that can swing down and engage in these holes in the tubing underneath to prop up the panel, pointing either to port or starboard. So on the mast crutch, the two goalpost pieces, I can't do it while I'm filming. Well, yes I can. There. Can slide right off. And so they really only need to be there at the moment the mast is being lowered, and can be stored otherwise. And then the, excuse me, there's a threaded shaft that goes between the two uprights here, and through the center of the roller, of course. And on each end there's two nuts, a regular nut and a jam nut. And so it's pretty quick work to take this down and take it apart. So, stealing an idea from the original General Boats installation, we've got a block of starboard down there attached to the vertical rail that the swim ladder clips into to keep it in place. And then we can pull the pin on the gate and swing that up into its own block of starboard, so we get better access to the swim ladder. If we wanted to improve the access further, we could swing the traveler out of the way. So in preparation for towing the boat down to Long Island Sound and launching it, we're lowering the mast, and we've just got it down into the new mast crutch. And we can see a couple of things here, one of which I anticipated, which is the need for the gap here in order for the boom to have some place to go at this point. The mast would have cleared had this bar gone straight across, but the boom doesn't. Something that I really didn't think about and anticipate is how close the spreaders would come to the solar panels. But they don't actually hit them. So close is good enough. And here we are with the mast down and pretty much ready for travel. There's a couple of things we got to finish up with, but we're not taking the boat for a couple of days, so there's no hurry. So I think that will wrap up this video about my new solar arch. We'll probably touch on the topic from time to time during cruises this summer, so stay tuned for that if you're interested in how it works out in real life. Thanks for watching.